On page 283, we're going to start looking at section 9.2 today. Section 9.1, I know we spent a lot of time in it. We looked at a lot of properties of radicals. For the remainder of chapter 9, we're going to be looking at how do we actually solve quadratic equations. Chapter 8, we spent a ton of time graphing them and getting familiar with them. Now, for the remainder of this chapter, we're really going to be looking at how do we solve those quadratic equations. And in lesson 9.2, our first way we're going to look at solving is by graphing. So a lot of those concepts that we worked on in chapter 8, they come back into play today. So today really is going to be a review section, really. On page 283, what you will see is a step-by-step of how we solve by graphing. Step number 1 says we need to write our equation in standard form. So if you notice, that's where we have all of our terms on one side of the equation. So we've got our term that's squared to the first power and our constant, and it's equal to 0. Step number 2, we're going to graph, and we are going to review today a couple different ways that we've used to graph. And last but not least, it says find the x-intercepts. That's nothing new for us. We did all these things in chapter 8. The solutions, aka the roots, are the x-intercepts of your graph. And again, this really does fit right in with what we did in chapter 8. The one thing we really didn't see in chapter 8, though, are graphs that had no x-intercepts or maybe only one x-intercept. We didn't get very familiar with any of those graphs. Most of the stuff we graphed in chapter 8 fit with our first property there, and it says we have two real solutions when the graph has two x-intercepts. And that's mostly what we saw in chapter 8. So we could have two real solutions. That's when we have two x-intercepts. So two solutions, two x-intercepts. One solution, we have one x-intercept. If you have one x-intercept, we saw that a little bit in chapter 8, but not much. One x-intercept, that x-intercept is your vertex point, which is either that minimum point, which is our lowest point of the graph, or it's our maximum point, which is the highest point on our graph. So if you only have one x-intercept, that is your vertex point. If you have no solution, that's when our graph has no x-intercepts. So when you have no solutions, that's when your graph has no x-intercepts. So let's dig into this. And like I said, it's mostly going to be review. So we need to refresh ourselves today on our graphing piece. And for a lot of you, it's going to be like, yep, you just need that quick review. And for some of you, I know chapter 8 was a little bit of a struggle. So here we have another shot at being able to graph our quadratics. So let's take a look at number 1. Step 1 says we need our quadratic in standard form. What do you guys think? Do we have that with number 1? Are we ready? Yeah, we've got our squared term, we have our term to the first power, and we don't have a constant. So if we wanted to, x squared plus 4x, what could I add on as my constant and not change my equation at all? I could add a 0 on. If you need to see all three terms, I know when we looked at standard form, we had ax squared plus bx plus c. So if you need to see that constant on there, you can always add a 0 in if you want. So let's just take a little refresher on how we would graph this. One method that we had is we could start by finding our vertex point. We had our small little formula we discovered in section 8.3, x equals the opposite of b divided by 2a. That gives me my axis of symmetry. That gives me the x value at my vertex. Once we have our vertex, we can make ourselves a little table of ordered pairs and get our graph from there. So let's start off using this method first, and then we will refresh on our second method we did. So when we take a look, we have x equals, here's the little negative sign that's part of our little formula. And again, we did this back in section 8.3, so if you need to ever look back at your notes, maybe we just put a little label here, lesson 8.3. So there's our negative sign from the equation. What's our b value for this one? B value is 4. All divided by 2 times a. What's my a value? It's a 1. Now I know I just heard a few of you say our a value is an x. If I put an x in there, am I going to be able to find anything?
Nope.
No. Keep in mind your a value is that coefficient, that number in front of that squared term. That's where your a is. So if there's not a number written there, it's 1. So we do a little simplifying. We get x equals negative 4 divided by 2. We get negative 2. So that gives us our axis of symmetry. That gives us where that middle of our graph is. That line that if we fold our graph in half, the two sides should match. It doesn't give me any points yet on my graph, but it tells me, hey, here's the middle. So if you fold your graph in half on this line, the two sides should match. So this gives me my axis of symmetry. Now let's find our vertex. Our vertex, we know the x value is negative 2. The x value of the vertex matches the x value of the axis of symmetry. If I know the x value, how do I find the y? If I know the x value, how do I find the y value? What do I do with the negative 2? Nick, what do you think? So let's plug our x value into our equation. So we have negative 2 squared plus 4 times negative 2. And that gives us our y value. I know our equation starts as equal to 0, but all we've done is we've replaced y with 0. We've substituted that 0 in for y. Negative 2 squared, remember, we substitute so we have parentheses. So this does come out to be positive 4. You have to be very careful when you're using your calculator. We have to use those parentheses around the negative. Otherwise, our calculator will tell us that's negative 4. So 4 plus negative 8, we get negative 4 for our y value. So negative 2, negative 4. I've got my vertex. Negative 2, negative 4, I've got my vertex. So I've got the middle of my graph. I've got the middle of my graph. So now once I have the middle, we can go to our usual fallback of, we can make a table of values. We can make a table of ordered pairs. And we're not going to do question 4, so don't worry if you're running out of space. So we have the middle value. I know my vertex is at negative 2, negative 4. So then I pick some numbers that are close to that negative 2 mark. So maybe I pick negative 3 and negative 4, negative 1 and 0. Now you might have to extend your table out. Again, we're looking for x-intercepts. We're looking for where our graph crosses the x-axis. So this table of values might do it for me. I might have to go beyond negative 4 and I might have to go beyond 0. So let's just take a few minutes. I want to give you guys a chance to fill in the table and kind of refamiliarize yourself with the computation and graphing those ordered pairs. Make sure when you're substituting your values in for x, make sure you're using parentheses so you're getting the correct squared value. Also keep in mind our little shortcut, our graph is symmetric, so our table should be also, so you only need to do really half of your table. You only need to do half. So if I put negative 1 in for x, I square it, I get positive 1, plus negative 4, we end up with negative 3. If I put 0 in, I get 0 squared is 0, plus 4 times 0, I get a 0. Again, our table is symmetric, so don't spend a lot of time then putting negative 3 and negative 4 in for x. You can if you want to. But remember, our graph is symmetric. So these two values should match. and these two values should match. Or you can use your axis of symmetry. My point right here is 1 away on the right, so I have 1 away on the left. My point is 1, 2 away on the right, so it's 1, 2 away on the left. Remember, we're looking for x-intercepts, and by doing that small table, I did come up with x-intercepts. I did come up with x-intercepts. My x-intercepts, you could get them from the table if you wanted to. You can also get them from the graph. Your solutions then, your solutions to the equation are the x values of the x-intercept. So my solutions to this equation, my solutions to number 1, x equals 0, x equals -4. Notice it's not an ordered pair that I'm writing. X equals 0, I realize there's a comma there, but please do not just put 0, -4. You need an x equals there. You need an x equals there. If you just tell me 0, -4, I'm going to think you mean the ordered pair 0, -4. So be very careful. We are looking for those x values. The other thing you can do, keep in mind, we are solving an equation. You guys have been solving equations forever. How do I check my answer? Put them back in the equation, substitute them back in. So if you substitute 0 in for x, the left side of the equation should equal 0. If you substitute -4 in for x, the left side of the equation should equal 0. So make sure, take the time to check your answers, but keep in mind you have to check them one at a time. Don't put 0 in for one x and put -4 in for the other x. You have to check them one at a time. So put 0 in for all the x's, make sure it works. Put -4 in for all the x's, and make sure that it works. So the method we did with question 1 is what we did in lesson 8.3. We used our small little formula, x equals the opposite of b divided by 2a, to help us find our axis of symmetry. We used it to help us find our vertex. And then once we knew our vertex, we could set up a nice table of values. We knew where the middle of our graph was, so we could set up a nice table of values. That was one option we had for graphing. The other option, another option I should say, not the only one, we're going to look at question 2. And we're not going to do 3, so if you need more space, we can go up above and we can work our way over by question 3. The first thing we have to start with, though, in question 2 is we have to get standard form. Now, when you go to get standard form, your equation has to be equal to 0. And one of the biggest things you want to make sure you do, write your equation so that your squared term is positive. I know when we've looked at things, we always have everything shoved over on the left-hand side. That doesn't matter. We can move things over to the right side as well. So again, just keep in mind, when you go to get standard form, we want our squared term to be positive. So in order to do that, we're going to add x squared to both sides. So we end up with 0 equals x squared minus 2x plus 1. You want to keep your squared term positive, even if that means you have to move maybe 2 terms to keep that positive. You want your squared term positive. It's just going to make graphing a lot easier for you. Once you have standard form, I'm going to put a little label up here where you could find examples like this one. This strategy comes to us from lesson 8.5. What we did in lesson 8.5 is we started off by finding our zeros, aka our x-intercepts. In order to do that, we factored. In order to find those, we factored. Now, we had a great shortcut Our leading coefficient is a 1. So we said we needed to add to get what? And multiply, or actually multiply to get, or it doesn't really matter. Multiply to get 1. Add to get -2. So we had to find our two magic numbers so that when we multiplied them, we got the constant, which is our last term. And when we add them, we get -2, which is our middle term. So what's going to work for us? What's going to be our magic numbers? -1 and? -1 and +1. If I multiply them, I'll get -1. We're on the right track. -1 and -1. Yeah. -1 times -1 gives me +1. -1 plus -1 gives me -2. Now I realized that when we did our factoring, we had a grouping method, we had a box method. Now is kind of that point where I'm hoping, after seeing it in Chapter 7, we saw it again in Chapter 8, now here we are again in 9, I'm hoping we can use the shortcut. When the number in front of the square term is 1, we can use this shortcut. Whatever our squared variable is goes first in each set of parentheses, and we fill in with our magic numbers. That was a shortcut we all discovered back in Chapter 7, and then it was kind of a take it or leave it. If you wanted to do the long way, you could, grouping or box. And then we saw it again in Chapter 8 when we did our graphing, and again we said, you could take the long way, grouping or box. But now seeing it for the third time, I'm hoping we can all just jump to that shortcut. I'm hoping. Then from there, once we factored, we solved by setting each of those binomials equal to 0. Now in this case, it's the same thing twice, so do I really need to solve it twice? No, I don't need to solve it twice. We get that our x value equals 1. Our x value equals 1. Our y value is at 0. X value is at 1. Our y value is at 0. So in this case, we just have one x-intercept. Now we talked earlier and we said when we only have one x-intercept, that's also our vertex. When we have one x-intercept, that's also our vertex. So 1, 0 is the middle of my graph. Now, since you're asked to solve by graphing, yes, at this point, we've got our x-intercept, so yes, we would have our solution. But I do want us to make sure that we continue on and we finish off our graph. Now, in order to make a decent sketch, I'm okay as long as you have 3 total points on your parabola. So if you already know, hey, I've got my vertex, that is my x-intercept, that is my solution, just find a couple more points so you can finish the sketch of your graph. I want us to stay sharp on being able to graph these. And again, just like with the first one, our table and our graph should both be symmetric. I think 0 is the easier number to substitute in, so I'm going to put 0 in. I'm going to get a result of 1. And then we just have a nice sketch of our graph. We have a nice sketch of our graph. Now, once you graph, though, you can't forget to actually answer the question, which is, well, what's the solution? The solution is your x-intercept, so in this case, x equals 1 is my solution. And again, we talked earlier, we could have 2 solutions, like we saw in number 1. We could have 1 solution, like we saw in number 2. Or, let's take a little scroll down. Let's look at question 9. How is question 9 different than the first 2 that we dealt with? How's question 9 different? What do you think? There's no just plain x term. There's no b term. So when this happens, when you just have that x value that's being squared, you actually have vertex form. This was lessons 8.1, 8.2, and 8.4. And again, how I can pick that out is I don't have just that plain x term. Any x I have is being squared. Any x I have is being squared. So the advantage of that is it can save us actually quite a bit of work. We have vertex form. When we add 4, I actually know my graph is going to move up 4. So my graph starts at 0, 0 originally. It goes up 4. 1, 2, 3, 4. That's the middle of my graph. That's my vertex. That's the middle of my graph. Again, I know it's vertex form because the only x in that equation is being squared. The only x in that equation is being squared. So take advantage. Use the transformation. It just goes up 4. Then that's the middle of my graph. That's the middle. So 0, 4 is the middle. And then I need to pick a couple ordered pairs, or a couple more numbers I should say, to get me a nice sketch of my graph. So the big idea here is if you can find the middle of your graph, we can just use our table to find the rest of it, if you can find the middle. So same as we've been doing, my graph is symmetric, my tables should be symmetric. So I'm going to stick to just finding this half of my table that has the positive values. So if I put 1 in for x, 1 squared is 1, plus 4 is 5. And let's just take a little pause right there before we do any more work. So then I'll have 1 at negative 1, 5. Which way is this graph opening? Is it opening up or down? It's opening up. Do I really need to make any more points on this graph? No. And if you're thinking, well, Miss Golly, wait, why don't we have to make more points? We usually do at least 5 points. Why don't I have to do any more points on my graph? We know it's not going to do what? It's not going to cross the x-axis. So as soon as you know your graph isn't going to cross, you can stop there. You can say no real solutions. And I'm just going to make a little side note here. No x-intercepts. And that happens. And that definitely happens. So if you know that your graph isn't going to cross the x-axis, stop there, finish your sketch, and then your solution, you have none. You're looking for x-intercepts. So on this page, what you see are the 3 different possibilities that you will see when you graph, when you're trying to find solutions. In question 1, we saw the possibility where we had 2 x-intercepts, so we had 2 solutions. In number 2, we just had 1 x-intercept, which is also my vertex, which is my only solution. Then in number 9, we saw a graph that didn't cross the x-axis at all, and when that happens, we have no x-intercepts, so we have no real solutions. That's the part we have to be careful of. It could be any of those 3 possibilities. It could be any of those 3. I do actually want to do one more with you with the graphing, because I want to make sure we're okay with the factoring piece. Because when we factored up in number 2, we just came up with 1 x-intercept. I want us to do one where we factor and come up with 2 x-intercepts. So on number 7, let's use our factoring method, like lesson 8.5. And I want you to go ahead and factor it. Find for me Find for me, actually, your x-intercepts, and then I want to talk from there about how we get the rest of our graph. So we add to get -1, multiply to get -12. Anybody have the magic numbers? -4 and +3. So we get x minus 4 and x plus 3. Again, take the shortcut. Don't mess around with all the grouping or drawing the box. You can if you want. But again, this is our third shot at seeing that shortcut, so I'm hoping that we're comfortable using it at this point. Set each factor equal to 0. And once you factor, you actually have your x-intercepts. You actually have your zeros, your solutions. But I want to make sure we can continue on and that we can finish graphing this, at least that we can find our vertex. So if you have 2 x-intercepts, all that I will ask of you to finish your sketch is to find the vertex. To find your vertex, remember, the vertex is halfway between those 2 x-intercepts. It's halfway between because our graph is symmetric. So the fast way we had for finding our vertex, to find that axis of symmetry, that middle value, we added our 2 intercepts together and divided by 2. So the x value of my vertex is going to be at 1/2. So somewhere along this line. And just like we refreshed on earlier in our first example, if I know x, all I have to do is substitute that value in for x into the equation and solve for y. So we should get -12 and 1/4 for our y. So our vertex, our vertex is 1/2, -12 and 1/4. So be careful when you go to graph your vertex. I'm not going to fit -12 and 1/4 if I keep my scale going by ones. But it will fit if I change my scale to 2s. And like I said, for these, especially since once you know your x-intercept, you know your solution, all I ask is that you just stay fresh on, once I know my x-intercepts, how do I find my vertex? That's the piece I want to make sure we stay fresh on. Our actual solutions, we already found those. They're already boxed up over here. X equals 4 and x equals -3. So again, I know if you factor, you find the x-intercepts very quickly. I still ask that you graph those x-intercepts and then also find your vertex. So if you have those 3 points, that is more than plenty for a sketch. That's more than plenty for a sketch.